Hi, I'm Bob Henry, Product Manager for Epilog Laser based in Golden, Colorado. Thanks for joining us today. We really appreciate you taking the time to be with us for this webinar. Today we're going to be discussing and demonstrating some exciting aspects of laser marking and cutting. Using both our CO2 and fiber laser systems, we'll be showcasing some of the most common industrial laser marking and cutting applications. For today's demonstration, we'll be using our Fusion 40 60-watt CO2 laser system on my left, and on my right we'll be using our FiberMark Fusion 50-watt metal marking laser system. These laser systems represent 26 years of laser system design and manufacturing experience by Epilog. The objective today is to demonstrate the different types of marks that can be achieved with the two different types of laser sources. We'll also be exploring some of the cutting capabilities of our CO2 systems. The materials we plan to work with today for the marking applications include industrial grade ceramic, black oxide coated steel, engineered plastic material, anodized aluminum, and finally some stainless steel. We'll also do some test cutting of gasket material and signage plastic using the Fusion 40 CO2 laser system. Throughout the webinar, we'll be discussing job layout techniques as well as our new job management software, which was designed to help our customers streamline the marking processes and improve workflow. Before we get started with actual laser marking, a few words about the differences between CO2 and fiber lasers. CO2 lasers are by far the most common type of industrial lasers and are used extensively for engraving, marking, and cutting applications with many materials including wood, paper products, acrylics, textile, cork, leather, rubber, glass, just about anything except bare metal materials. Fiber lasers like Epilog's FiberMark series are used for marking applications on metal and engineered plastic materials. The wavelength of light generated by the fiber lasers are generally not used for wood, glass, textiles, paper products, and similar organic materials. With that introduction, let's start exploring what these lasers are truly capable of. As we talked about in the introduction, we're going to work with a variety of different materials today. We're going to start with some ceramic material. We're also going to do some anodized aluminum, black oxide material, engineered plastic, and then some steel. We'll show you with this steel some common large tool marking applications, so this will be a good demonstration for you. And then we'll also do some cutting applications with different type of gasket material, and then finally some signage, engraving and cutting with some typical sign plastic material. The first material we're going to work with today is this industrial grade ceramic material. Not sure if this is going to mark better with the fiber wavelength or with a CO2 wavelength light, but we're going to find out. We'll test in both machines and we'll compare and contrast those different types of marks. The first machine we'll mark with today will be our CO2 Fusion 40 machine. This machine has a 40 by 28 inch work area, quite large, obviously able to accommodate multiple small pieces or larger pieces as well. For purposes of the demonstration today, we're just going to do some small field marking. If we're going to do that, we place everything in the upper left corner of the engraving table. So we'll place this up in here, and then we'll need to focus. We need to have the correct focal distance for the laser to mark on the material. This is our manual focus gauge. We hang it on the lens assembly like that, and then at the control panel on the laser, we will hit the focus tab and raise the laser, or rather the table up until it just touches on the material, just like that, and then we can remove the focus gauge. We also have in our print driver the ability to do a manual, or rather an automatic focus based on material thickness. So the material's ready to go. We're in proper focal distance. A quick note about Epilog lasers: they're compatible with a wide variety of software programs. We're going to be using CorelDRAW for our demonstrations today. Our laser systems work with Adobe Illustrator. They work with AutoCAD, SolidWorks. Bartender is popular for our customers that are doing a lot of barcoding applications. Also happy to report that we now have a Mac driver. For those customers that like to use the Apple products, we have a driver that'll work with our Fusion laser system products. Again, we're ready to go with the marking. Let's spend a few minutes in the software and talk about how we're going to lay up this job. Okay, let's do a little work on the software side. First thing I'm going to do is zoom out and show you what this page setup looks like. You'll notice that this space here is a 32 by 20 inch work area. Our customers will set this up differently depending on what their preference is. For this demonstration, I'm going to set this up as 32 by 20, so we have similar bed sizes between the Fusion 40 machine and then the FiberMark machine. Here's our graphic image that we've got set up. We're just going to print Epilog Laser onto that ceramic. You'll also notice that we've got this box drawn here. That box is the actual size, 4.5 inches, of the ceramic piece. One of the really nice things about the laser systems, of course, is the large work area. We recommend that our customers gang up as many pieces in the machine as possible so they can maximize that space. In CorelDRAW, and similarly in other software programs, there are tools that allow you to essentially populate that entire space. In CorelDRAW, I can populate this space by simply giving a command to add more of these text objects into that area. And then I can do this downfield as well. I can hit apply to the y-axis as well, and we'll populate the y-axis dimension also. So now we have our graphic file that's built. We're able to load as many of those pieces into the table on the laser that will fit. This is a great way to do multiples in one job, very easy to set that up. Again, for purposes of today, we're just going to do one of these pieces, and so I'm going to select this one particular item in the upper left corner. We'll zoom in on that again. And we're basically ready to print at this point in time. Once we've got the graphics set up and we have the items selected that we want to mark, I'll go to our print driver. So you click on the print icon, and then you'll select the print driver for the laser system. I'll note that our lasers work off of USB or network connectivity. What's nice about network connectivity here is that I've got both lasers hooked up to one computer. Simple network connection going to a hub, and then network connections to each laser. So once we've selected the print driver that we're going to use, we're going to direct traffic to this CO2 laser right now. I click on the Preferences tab. This is our print driver. I won't spend a lot of time in here other than to say that it's a very powerful tool that allows you to do a lot of really neat things. First thing I'm going to do is select CO2 versus fiber, because we're going to be using the CO2 laser. Autofocus, I mentioned, if we wanted to use autofocus, and we'll do that in a later job today, I'd select that. We're not going to use autofocus today, so I'll leave that alone. Once I've set the parameters for this job, raster is what I'll select here. Raster would be sort of like an engraving, a printer, where a vector image is more like a plotter. And we'll do some vector cutting as well later today, so you can see the difference between the raster and the vector. The image that we're doing today will be a raster. I'll set the laser parameters here. I'm going to run some high power on this and fairly low speed to see if we can get a nice contrasting mark on that ceramic material. I'll also point out here, this is an important addition to our print driver. We have a send to printer and send to manager. If I select send to printer, the job is going to be sent directly to the laser system. I can run the job once the job has arrived there. Also, the send to manager, we'll get into this in just a minute, but that's going to send the job to our new print manager that's just been introduced. We'll go over the print manager in the next job that we do. I want to just show you quickly the standard print driver that we use to communicate with the laser and apply settings for different jobs. So right now we're ready to go. We're ready to print this job. I simply click OK and then print, and that job is sent to the laser. One thing I want to check here, recall that I selected just this item. That's the only one that I want to print, so I'm going to go back here and make sure that selection is selected, and indeed it is, so we are ready to go. Now let's go over to the laser and mark on the ceramic material. The first thing I'll do is go to the control panel on the laser and go to the job function. We'll see our job populated there. It's ready to go. We'll close the door on the laser system. It's important to note that Epilog builds all of our laser systems as Class 2 devices, which means that they're fully enclosed. There's no chance for the laser beam to escape the cabinet. We're ready to mark at this point. All I need to do is hit the go button, and you'll see the marking process taking place. Bit of a bright white coming off of there. Yeah, there's again no chance for the laser beam to escape the cabinet, so there's no physical laser beam leaving. Almost done here, and then we'll take this out and have a look at that mark and see how it looks. Well, that's got a nice contrasting mark there. Bit of a gold type of color on there. I'll point out as well that many of our customers in the ceramics industry will do testing on the marked ceramic. What they're interested in is finding out if the laser process is causing any damage, so they typically would do a dye test where they submerge the ceramic in a dye material, and through that process they were able to identify any sort of cracks. Let's now take the same ceramic over to the fiber laser and see if we can produce a mark on that machine. Okay, we've got the material in the fiber laser system now. I'm going to close the lid here. We've already sent a job over, so the laser's ready to go. You'll notice that there's a green window here. There's an organic dye in this Lexan material that absorbs the fiber laser energy. So again, no chance for that laser to escape the cabinet. So I'll select this job, we'll run it, and we'll see if we get any type of mark on the ceramic with the fiber laser. Again, you see a little bit of brightness at the surface of the material. Not as much as the CO2, but when this is done, we'll pull it out and compare. All right, the beep tone tells us the job is done. And you'll notice that we actually get marks with both wavelengths of light. Sometimes this is personal preference on which wavelength meets the needs of a particular material. Sometimes it's more dependent, of course, on the dye testing that is done. A customer might do dye testing and find that the CO2 or the fiber laser might cause a little damage, so certainly that will help to dictate which laser would be more appropriate for a given material. Okay, let's move on to the next material. Okay, the next material that we're going to work with is a black oxide material. This is common industrial coating for many metal materials. Oftentimes it'll depend on the type of black oxide coating, but the fiber laser typically produces a nice bright whitish mark, where the CO2 laser will produce a mark but not as contrasting. So we're going to run this. You'll see that I've got one of the pieces set up in a little V-block, a pen jig. So we're going to focus on that. I'll do some work at the control panel of the laser system. I'll bring this over, I'll flip this around, drop it right in there, and then we've got a really neat feature built into this laser system where I can change the home position and set up a new 0 location for where I want that mark to go. So you see I'm moving the gantry around, moving it left and right. I'll turn the red diode pointer on. You should be able to see that. You'll see that right on the material. I'm going to use that as my locating position for the material. First thing I'll do though is focus. You can see that the focus gauge here is hanging much below the part, so we need to focus to the right location. So I'll use the focus function on the control panel of the laser, bring it down, and then I'll just drag this over here and we'll focus back up until that gauge touches off on the material. That looks pretty good right there. I'll put this back in place, and again you'll see that red dot on the material. I'm going to capture that location as my new 0 position. So I'll do that. Now we've set a new 0 position in the laser. Again, this is great for prototyping or one-off type of marking. Ideally, if you're marking batch items, you'd have multiple V-blocks in here and you'd have as many items in this 32 by 20 space as you can fit. Again, really easy to set that up on the software side. So everything's set with the laser. Let's again go back to the software and we'll talk about how we'd set up this particular job. Here's the graphic that we're going to use, a simple made in USA text body for this particular image. Remember that ideally we're going to set up as many pieces in the laser as we can, but for this example we're just going to use the center engraving function and engrave or mark on one piece at a time. So we'll go to the print driver, and again we'll select the output device that we want to use. This is the Epilog Fusion 3.8 network location address that we've specified for that. We'll click on the Preferences tab. And again, back to our general driver. Here we want to select fiber. This is a raster type of engraving job as opposed to the vector, which we'll go over in a little bit. Here I'm going to select center center. That will be an indicator in the print driver that we've selected a new home position. And here I'm going to not send this job to the printer, but I am going to send it to the manager because I want to go into our new print manager and explain what we're doing there. The raster settings that I'll use for this, I'll go high frequency, maybe about 50% power, and then I'll go high speed as well. Actually, I'm going to reduce that power just a little bit, maybe to about 45%. Different dithering patterns are available. These will produce slightly different effects. I tend to like this Stooky pattern. That's kind of a customer preference type of setting, but with this, we're ready to go. We can simply click OK and then print. Now this job has been printed to our print manager, but not to the laser itself. So let's bring up the print manager and we'll go through this a little bit. We've got two lasers specified in our print manager. We've got the FiberMark 30 watt, and we've also got the FiberMark, or rather the CO2 Fusion 40 watt system. We've got a number of jobs already set up in here. This is the job that we just sent over. You can see the speed, the power, and the frequency here. You'll notice here that under the All Jobs category, we have uncategorized jobs, and then we have the GS, or Global Spec Webinar. When I send a job over from the print driver, it goes into uncategorized. That's where we are right now. So this is the job that I just selected. If I wanted to put this job into a different folder, subfolder, I simply click on it. I go here to uncategorized, and then I'll dump that job into our webinar folder. This is really handy if you've got a bunch of different applications, a bunch of different materials, or different customers. You can set up files specific to each of those. And here, this is just general information about this particular job. Again, we've got 100 speed, 45 power, and 100 frequency set. It's a fiber laser. It's a combined job, we say, but it doesn't really matter. We're just going to be doing raster on this. I'll click on Save here, and we'll go back to our GS webinar folder. There's that job that we just put in there. So we're ready to go. Everything is set up in here. I'll point out here under the material settings that this is really handy. We're going to be populating preset values for different materials. You'll see under annealing, we've got some pre-established settings. When our customers load up the print manager on their computer, whether it's for a fiber or a CO2 laser, these preset parameters will be included with that. Of course, you can change those. Each customer might have a little bit preference, a different preference on the type of look that they're getting, so they may change the settings a little bit, but this is going to be a really handy option for our customers to have these materials settings already processed for them. And of course, you can add to those as you go along as well. So back to the jobs. Here's the job that we want to run. I'll click on this, and then I simply just click on the print button, and that job is sent over to the laser. You can see we get the printing icon. The job has arrived at the laser. Now we're ready to print. With the job delivered to the laser, then we can just go back and verify everything that we've got with our sample in here. Remember that we've set a new position. The red spot indicates our new 0 or center position. We've got the focus in place. We're really ready to mark at this point in time. So we'll close the lid and hit the go button on the laser, and we're marking. There's the mark on there, a nice clean made in the USA, nice bright white mark on that one. Typical of what we would find on a black oxide material. Let's do the same thing now with the same material in the CO2 laser. We've got our material loaded up in the CO2 laser. You'll see that I've just got it in the center of the table here, again using the center function, really handy for prototyping or odd shaped pieces. You'll see the red dot pointer illuminating on the part there. That's going to be the center of our graphic. We're ready to go at this point, so I'm going to close the lid, and then we're going to go over to the software and talk about how we set that up through the Epilog Job Manager. So at the Job Manager, The first thing I'm going to do is select the laser system where I want the job to go. So I'll click on the Fusion 40 60 watt, and then I'll go into the jobs folder. You'll see that I'm still in the subfolder for this global spec webinar, and I've got this job sent right here. I can click on that and I can change this to a different type of laser. I'm going to change this to CO2, and then I'm going to change the laser parameters here. I know with a CO2 laser and black oxide that I need to run much slower speed and higher power to get the mark that I want. So I'm going to set that at 20 speed and 100 power, and then I'm going to click on Save. Before I do that, I could print this job over to the laser now by selecting the print icon, but let me save this first. You see that I've got this job selected. It's now populated as a CO2 job with those parameters that I put in there, 20, 100 for speed and power. And then I can print the job here as well. Now the job has been sent over to the laser. All I need to do is press the Go button on the control panel, and we're ready to go. This is a pretty quick mark regardless of laser that you use. And with the Fusion, we're running at a much higher speed than we are with the CO2 laser. But I want to pull these two parts in here and show you the difference in sort of mark color, if you will, between the fiber and the CO2. Generally, the fiber produces a whiter mark on black oxide material. The CO2 laser does produce a mark, but it's not quite as vibrant. Another thing I'll point out here is that it looks like the print or the text is smaller from the fiber laser marking. This is because of the fiber laser has a very, very small spot size, much smaller than the CO2. While the CO2 produces a great mark, there is a little bit of print growth on there. And again, because of the small spot size of the fiber laser, we just get a lot more clarity on that mark. So that's black oxide. Most of the time, you'll find that black oxide will mark better with a fiber laser, although you can produce some nice contrasting marks with a CO2 as well. Let's move on to the next material. Next material up is an engineered plastic material. This is typically a one-color plastic that reacts quite well, usually with a fiber laser wavelength, but not so well with the CO2. We've got the material set up in a CO2 laser right now. Of course, we'll run this in the fiber laser and contrast results. Again, I've got this job set up with center functionality in place. We're going to mark where that red spot is on the material. Notice that we're way out of focus as well. This is intentional. I want to, in the print driver, establish autofocus, and that's based on the material height. So we know that this is our zero reference point. The top of the material then is 0.43 inches above that zero reference point. When I program that through the print driver, then the table will come up and then the engraving will start. So autofocus function as opposed to a manual focus function for this job. Coming back over to the computer, you'll see that we've got the graphic set up here. This is a typical graphic that a lot of our customers use, more of a branding or logo type of marking effort. This particular logo you'll see has different colors in it, different shades of gray. The nice thing about the laser, all of our lasers, is they pulse in dot density relative to the color or the grayscale, which produces a really nice effect. So with this particular job, we're going to go to the print driver. We'll select print. This is the driver that we want to use. And here is all of the settings again for this job. Let's select CO2 laser, of course. Here's the autofocus that I talked about. So I'm going to select this autofocus, and then we'll type in the thickness of this material, which is 0.43 inches. The thickness is established now. That's what's going to tell the laser table to move a certain distance to provide the proper focal plane for this job. We're going to send this to the printer and to the job manager. And let's use some settings. A 60 watt laser here, a fair bit of power. Let's maybe go with, let's try this at say 75 speed, 100 power. And see what kind of results we get with this. So once we've got all the parameters set for this job, this all looks good. I'm going to click OK and then print. We go back into our Epilog job manager. You'll see that we're going to select this laser system, and then we'll go to the jobs. I want to go to the uncategorized jobs. This is the last job that we did here, and so I'm going to open this. I'm going to save this into our webinar file. Again, a really handy feature for you to file different jobs under different subcategories based on material or customer or a particular application. So here it shows that we've got autofocus on, we've got the thickness of the material prescribed, we've got the engraving speed and power set here. It's a CO2 job. We can print from this location, or if we go back here, we can print from this location. Again, this being our job. Actually, that's not our job. Let's go to the GS webinar. There's our job right there. So now we're ready to print this, and all we got to do is hit the printing icon. The job is then sent over to the laser. We'll close the door on this, and we'll notice that the table will raise again to the correct focal plane before the actual engraving starts. You see a little bit of smoke coming off of there? All right, let's take this out of here. You'll notice that the CO2 laser is actually engraved into the material. It's left a little bit of residue on there as well. That would probably come off, and you can see that there's a bit of dithering pattern in there. In some cases, providing depth into the plastic may be desirable. In some cases, not. With a CO2 laser with this type of plastic, it's possible that you could color fill this to provide a red, a green, or a blue type of color in that image. A CO2 laser would be a perfect application for that. Some people may prefer, if it's a material that needs integrity where we can't actually engrave into the material, we'll find the fiber laser probably will produce a little bit better mark. So CO2 laser, engineered plastic. Let's move over to the fiber laser and see what kind of result we get there. Okay, we've got the engineered plastic material set up in the fiber laser now. I've actually focused using our manual focus gauge. So let's just do a real quick step here. We won't actually go into the Epilog Job Manager. I'm just going to show you how quick and easy it is to send a job directly from our print driver. So print, we'll go to the device that we want, 3.8. We'll hit Preferences. This is a fiber laser. It's a raster job. With this material, I'm going to run at about 70 on all of the parameters, speed, power, frequency, and focus. In fact, let's go down to about 60 on those. We should produce a pretty nice result with those. So right around there should be a good result for us. Oops, let me get the Stucky dithering pattern in here. And everything is set to go. We'll run this job right now, so I'll click OK, and then print. Jobs delivered to the laser system, and we're ready to go. There we go. So you'll notice that with the CO2 laser, the previous mark, we had some smoke coming off, some discoloration. This is a much cleaner type of mark. Also, I've set this up to engrave from the bottom to the top, which is a very handy type of feature for some sign plastic engraving applications. So this is almost done here. We'll take this out, and then we'll compare those two different types of marks. All right. So you'll notice that the fiber laser produces a much greater contrasting mark. It's much darker. And while it's difficult for you to see on film here, we have depth into the material with the CO2. Here we have actually just a surface type of mark. We're changing the chemistry of the plastic. It's called a foaming technique, but it changes the color of the material, and in both graphics you'll see that grayscale image is represented fairly well. So depending on your needs, what the requirements of the plastic marking are, whether a CO2 or a fiber would be a better choice. I'll tell you, most of our customers prefer the fiber type of mark over the CO2. It's a quicker mark. And produces a better contrasting mark typically on these plastic materials. So enough on plastic, let's move on to some anodized aluminum. Here we've got the anodized aluminum piece that we're going to mark on today, slotted in the laser. We've got it nested up in the upper left corner, Again, we're using the center engraving function. Where that red dot is indicated on the part is where our mark is going to go. We're going to do a barcode on here with a human readable component as well. Ideally, our customers would load up the entire bed of the laser with as many parts as possible, but for today's demonstrations, again, we're just doing one-up parts. So let's go over to the computer and we'll set this job up to send the print commands over. Here we've got the graphic file set up. This is our data matrix barcode. The data matrix code is by far the most popular code for industrial applications. We still see some linear barcodes out there for marketing applications, sometimes a QR code, but this data matrix code is very popular. So let's go to the print on this one. There's our driver that we want to use, and then let's go in here and set up some parameters. Fiber laser, that's correct. We're not going to use autofocus here. We are going to use center engraving. And then let's just send this to the manager and not the printer. Let's see, those parameters look good for this mark, this material. We can run this at a high speed, high power, and get a nice bright white mark on here. So everything looks good here. Let's click OK, and then print. Then let's go into the Epilog Job Manager, and we'll select this laser. And then let's go into the jobs. The uncategorized jobs, there's the job we just sent. For housekeeping purposes, let's dump this into the file that we're using for the webinar. Everything looks good here, 100 speed, 100 power, autofocus is off. It's a fiber job, and let's just simply print it from here. Pretty convenient. You can print from a variety of different locations in here. Job storage, material settings, and the new job manager. So let's close the door on this, and our job has arrived, so let's hit the go button and let it mark. If we're doing multiples here, you'd see the lens assembly moving across the page left and right to fill up the entire marking field, and as it moves downfield in the Y dimension. The barcode's just about done. Now it's doing the human readable component. Let's take a look at that mark on there. Oh yeah, that's a nice bright white mark on that anodized aluminum. Again, when we put this in the CO2 laser and do the same type of mark, we'll find a little bit of difference. I'll be happy to point that out to you. So let's take this over to the CO2 laser and we'll do the exact same mark right adjacent to it. Okay, same material in a CO2 laser here. You can see hopefully through the glass that we've got the red dot indicating the location of this mark. And then let's go into the job manager. We'll select the laser we want to use and go to the jobs tab. We'll go back to the uncategorized where we are, and then we'll bring up this job, and let's put that back into the webinar folder. We'll save that. Let's take a look at this. The speed that we've selected here. Oh, actually, we need to go into here. Here's our job. We've selected from the print driver 50 speed, 50 power, but let's actually change this a little bit. And so we're going to edit this job. We're going to go in here and make this 100 speed, and we'll keep this at 100 power as well. And let's see if we can get some nice results here as well. So I'm going to save that, and we are ready to print. So I'll click on the print icon. Job comes over to the laser. We'll press the go button, and we're marking. All right, let's take this out of the laser and we'll compare those two marks. Might be hard to see here, but the fiber laser mark is whiter in appearance than the more grayish toned CO2 mark. You'll also notice that the marking area is much finer with the fiber laser. Again, this is because of the beam width on the fiber laser as compared to the CO2. We've tested both of these codes previously, and of course they both scan quite nicely with a barcode reader. So that's kind of the general effect that you'll find mostly with an anodized aluminum material, is that with a fiber laser you get a whiter type of mark with a smaller resolution or finer resolution, and with the CO2, still very good results, but a little bit grayer in color. Let's move on to the next material. The next material that we're going to work with is some steel material. I'd like to explain how you can mark on bare metal materials with a CO2 laser. Because of its wavelength, the CO2 laser is not great for marking on bare metal. You can use some really small focal length lenses. You can use a high power and slow speed to get some results with CO2 marking on bare metal, but generally it's not consistent and not terribly reliable. Most people with CO2 lasers marking on bare metal will use this process that we've described on this little sample board. Bare metal, spray a special coating onto the surface of the metal. This is readily available in the market. Laser the material, laser the steel with the coating on it. This is what it looks like. And then when you wash off the excess coating, you're left with a nice black permanent mark. This is a great option for customers using CO2 lasers for wood, plastic, glass, textiles, and also need to do a little bit of metal marking. So this is a really good solution. We're going to do both the coating marking with a CO2 laser and then the fiber laser on this tool that we have in the laser right now. On this tool, you'll see that we've got some of this coating applied to the surface of the metal. We've got the red dot indicator in the center of the graphic. We're set to go. We've selected the focus. One thing I want to show you though, it's a really handy feature for making sure that you're going to be marking in the correct location, is to set up a vector line, a box essentially, around the image that you want to mark. In this case, I've got the box just around the words laser group. I'm going to send a quick job over to the laser. We'll do this in vector mode. When we run the job, we're going to watch the red diode trace the outline of this laser group text to make sure that we're going to be marking in the correct location. So I'll click OK. I'll print that job over. I'll go over to the control panel on the laser and hit the go button, and then you'll be able to see the red diode move. Laser group will stay within that marked space. That's exactly what we want. So now let's send over the actual text body. Back to the computer. I've selected the laser group here. I go to the print icon. I select the laser I want. Here, I'm going to do selection only. I don't want to do Epilog. I just want to do the term laser group. So we'll select that. We'll go into the Preferences tab, CO2 laser. No autofocus on this job. We are going to use center. Let's go back to the job manager. When we send this job, let's go in there and do some manipulating. This is going to be a raster job. We know with a 60 watt laser and this coating material that we need to use high power and a little bit slower speed. So I'm going to go to about 35 speed on this with 100% power on this 60 watt. Should be sufficient for the laser, the CO2 laser, to bond this coating to the surface of that metal. Once I've got all the parameters set, I click OK and then print, and then again let's go into the job manager. Let's select the laser system that we want to use. We've done that. It's our Fusion 40 60 watt CO2 unit. Let's go to jobs, uncategorized jobs. This is the one that we just sent over. I'm going to recategorize that. Actually, I'll select it and then recategorize it here. I'll put that into our GS webinar. All of our settings look good, 35, 100 for speed and power. It's a CO2 job. I'll save that. And let's see here. Go to the GS webinar. Here is our job right here. We're ready to run this. So all this looks good. Let's hit the print button. We'll close the lid and we should be producing some nice marks on that surface. Okay, we'll open up the door. The next step in this process would be to wash off the excess coating. which we'll do. And then we'll go over to the fiber laser and we'll do Epilog up here with the fiber laser so we can show the different types of marks. So let's take a brief pause here and we'll go over to the fiber laser and we'll set it up to run Epilog. We've moved our tool over to the fiber laser now. You can see the laser group is marked on there with the CO2 and the coating process. We've set this up now to engrave directly onto the metal with the fiber laser. So let me go back to the computer here. I'm going to select the text I want to engrave here, and then I'm going to click on the print button. We'll go back into the print driver. We're going to send this one to both the printer and the manager. And we've got center selected. This is a fiber laser. It is a raster job, so I'll select that. And I want to set this up with some laser parameters are going to do a nice job of etching into the metal. So I'm going to set frequency low, the power high, and then with a 50-watt FiberMark fusion, I should be able to run this at about 25 speed and get a nice deep mark into the metal. Once I've done that, I click OK, and then print. And then let's go back into the Epilog Job Manager. We're going to select this laser. The jobs that have come through uncategorized, there's our job right here. For housekeeping purposes, let's load that into the file that we're using here, the GS webinar. We'll save that. Again, all the parameters that we want to run with this job are listed right here. 25 speed, 100 power, 1 frequency. That looks really good. I like that. That's going to be a good setting for us. So we can simply print that over to the laser now. And the job has been delivered. We'll close the door and start the marking. There we go. The advantages of a fiber laser over a CO2, of course, are the direct metal marking. We haven't found a metal yet that we can't produce a good mark on with a fiber laser. The CO2 holds advantages, again, because it allows our customers to work with those other materials and still do some marking on metal using that special coating. It sort of depends on the throughput requirements of a particular customer and what they need to get done. Most of our customers that are doing just metal marking will prefer a fiber laser. They don't want to take the time to spray on the material, the coating that is, and then wash it off after the fact. So it really kind of depends on the group of materials that our customers are using and their cycle time requirements. Always a little bit of dust that comes off that mark. We'll just wash that off right there. You'll see they look very consistent, very similar. The FiberMark mark is etched into the metal. That is a very permanent mark. You'd have to remove the metal to remove that mark. The coating mark with a CO2 laser is bonded to the surface of the metal. It's quite durable if it's prepared right, if the surface is clean before you apply the coating and you have the right thickness of coating on the material and using the right combination of speed and power, it's quite a good mark as well. So a quick summary of the different types of marking applications on metal, CO2 versus fiber. Let's move on to some cutting applications now using our CO2 laser. The next thing we're going to work on in the CO2 laser is some gasket cutting. We've got 3 different types of gaskets. This is a very common application with CO2 lasers, these types of cutting applications, whether it be a paper product, a wood product, a textile, gasket material, a lot of industrial and more light commercial applications for cutting work in the CO2 lasers. So I want to turn our attention over to the computer for just a minute. I'm going to talk about how we've set this job up. You can see that we've got the 3 different gasket materials lined up there. I've got a gasket that I'm going to cut in each of those materials. I've set up the program, I've set up the job in our standard print driver, and I've sent that job over to the Epilog Job Manager. What I want to do here is talk about some of the efficiency that you can gain with this type of system. First thing I want to do, well, back up a little bit. If I've got a customer that's coming to me every week and telling me, I need these gaskets, I need 100 of these every week, you can do those in one day, of course, and you're only dedicating a little amount of time for that each day, and then you move on to the next thing. So what you can do is to create a file in the job manager. So we're going to create a new file. We're going to call this the Gasket file, and we're going to save that. Remember, when we send a job over, it comes in and uncategorized. Here's the job right here. You can see this is the gasket information that we've got on here. We have different colors, which I'm going to describe in just a minute. But I want to save this to the Gasket file. I'll click on Save there. Now we've got a gasket folder. We have those customer gaskets in there. The really nice thing about the Epilog Job Manager is that next Monday, when I need to cut some more gaskets for this customer, I don't have to open CorelDRAW or AutoCAD or whatever drawing program I have created those gaskets. I can simply go to the Job Manager, bring up this file, and run it directly from the laser. So a really handy interface. Again, capturing jobs here in the Job Manager. Very wonderful tool. Let me go back here. I want to talk about this just a little bit more. Again, blue, red, and green. This is something that we can do with our systems. We call it color mapping. By assigning colors, we can specify that we want different speed and power values for those different colors. So I need to use a little bit different speed and power combinations to get through these gasket materials, and I've assigned that through color mapping. So what we'll find is that each of these are going to be cut individually using those different laser parameters. So it allows me to do different types of work with different materials in one job setup. We can even color map the focus. If we've got a thicker material, we can have the table lower to get in the right focal plane for that material as well. So really setting up the job for the different materials, the different thicknesses, and having it reside right here is a perfect example of how we can do this. So let's run this job now. We've saved this, and all we need to do is to click on the print button, select it. Now it's printing to the laser. Now we'll close the door and we'll run this job. Now this will all be in vector mode, where we're cutting all the way through the material. You notice it went to the middle section first. That's because I had the color map set up that way. The first color that shows up in my color map column is the first object that gets done. And back to the last sheet here. All right, job's done. We've got some nice clean gaskets cut there. Pretty efficiently, very easily done. We'll just pull these out here and see that we've got some nice gasket material. Very quickly, very efficiently, we can create gaskets. This is wonderful for prototyping, especially where you need to change the shape of it just slightly. Instead of using a steel rule die, which is cost and time, you can use a laser to prototype these things. And it's really good for production as well. So another good example of cutting applications with a CO2 laser, gasket material. The same would apply to wood, paper products, textiles, other materials as well. Let's move on to the next material. We're going to do some sign plastic. We'll do some engraving and cutting with that. The next and final material we'll work with today is common sign or architectural plastic. This is great material. Typically we'll have two colors on it. The laser is going to remove the top color to expose the bottom color. We'll be able to engrave and cut this. This is a great demonstration to show sort of the dual capabilities in one job of both engraving and cutting. So we've got a graphic set up. We'll put the material in the laser. We've already pre-focused. We'll close the door. And back at the computer, we've also sent this job over to the laser. So the first thing I do in the Epilog Job Manager is select the laser that we want to use, and then I'll go to the Jobs tab. And recall that the job, this is the one we're going to do right here, caution, comes in under the uncategorized jobs. So again, if we want to use that example of setting up this job for a routine customer, we can simply create a new file. We'll call this SIGNS for signs. Oops. And we'll save that. So now we've got another folder where we can store more files. We'll click on this, and then we'll categorize this under the signs. Here we've got all the parameters for this job. We're going to run this at 100% speed, in raster mode at 30 power and a frequency 50. In vector mode, we're going to run at 30 speed, 45 power, and frequency of 100. It's a combined job, CO2 laser. We are ready to go. So I'm going to save this. Go back to our signs folder. There's our file right there that we're going to run. We'll click on it and then simply print it to the laser. Again, this is really handy for me if I'm going to come in next week and bring up this same job for that same customer. I just go to the Epilog Job Manager, send that file over to the laser without actually having to pull it up in software. So the job is at the laser. We'll hit the go button and we'll start marking. Always a little residue that comes off. You'll see that we've got a nice new industrial architectural sign. Well, that about wraps up the demonstration portion of the webinar today. It's about time to head into the Q&A session. We hope these demonstrations and sample preparations offer you some insight into the variety of marks and cuts achievable with lasers, both CO2 and fiber. With literally hundreds of different material types available in the market, it's sometimes difficult to know which laser is appropriate for a given material. The best way to know, of course, is to test your material, which we're happy to do here in our applications lab in Golden. Give us a call or send us an email. We'll be happy to discuss your specific material in more detail and perform some applications testing for you. Thanks again for joining us today. We really look forward to hearing from you.